The roar of the engine shatters the silence of the airfield. A narrow, unusually long nose, the fuselage trembling from the barely contained thousands of horsepower hidden within. A sharp push and the aircraft surges forward. The air wraps tightly around the wings, the ground below turns into a blur, and the horizon tilts, giving way to the endless blue. NASA's Quest mission, short for Quiet Supersonic Technology, aims to redefine supersonic air travel by eliminating the disruptive sonic boom. At its core is the Lockheed Martin X-59 Quest, a sleek 99.7-foot single-pilot experimental aircraft built by Skunk Works, designed to cruise at Mach 1.44 or 925 miles per hour at 55,000-foot altitude. Instead of the traditional boom, the X-59's long pointed nose and carefully sculpted airframe diffused shock waves to produce only a faint sonic thump about comparable to closing a car door. At the legendary Lockheed Martin Skunk Works facility in Palmdale, California, engineers are constructing one of the most ambitious experimental aircraft in aviation history. Construction of the X-59 involves a modular approach. The fuselage, wings, and tail are built separately using lightweight composite materials and advanced manufacturing techniques to achieve aerodynamic efficiency. These major components are then mated using precision-engineered jigs to ensure exact alignment and structural integrity. At the heart of the aircraft is the General Electric 414 GE100 turbine engine, the same power plant used in the F/A-18 Super Hornet. Getting close to that. Keep it coming. Slow down a bit. However, its integration into the X-59 is tailored for quiet performance with the engine buried deep into the fuselage to help muffle sound. Music, every step of the assembly is guided by strict quality and performance standards, preparing the aircraft for extensive ground testing, taxi trials, and eventually supersonic test flights. Once complete, the X-59 will take part in community overflights where residents help determine how noticeable its sonic thump is, critical feedback for regulators. As part of the extensive testing for NASA's X-59 Quiet Supersonic Technology aircraft, the U.S. Air Force and NASA have teamed up to conduct aerial acoustic validation flights using an F-15 Eagle. Now, we're testing out on the F-15 by flying up at altitude and probing another F-18, which is used as the target aircraft. Typically the F-15 starts in trail and outside the shock signature of the target aircraft, and then we accelerate, so the probe pierces the shocks and essentially we go all the way through the shocks, and we can see that in the control room, and once we've seen that we've essentially pierced through the bow shock of the F-18, we will ask the F-15 pilot to decelerate and take another measurement. These flights are critical in verifying the low-boom design of the X-59 before it even takes its first flight. An 836, confirm when in position. The F-15 serves as a test surrogate, flying specific supersonic profiles over ground sensor arrays and microphone fields. During these missions, the F-15 is equipped with specialized test hardware that mimics the expected shockwave pattern of the X-59. By flying similar flight paths at supersonic speeds, researchers on the ground can study the resulting sonic signatures and adjust predictive models accordingly. Developed by the Atlanta-based startup Hermes, the Chimera turbojet engine represents a significant advancement in hypersonic propulsion technology. It is a turbine-based combined cycle engine, which means it combines elements of both a turbojet and a ramjet. This hybrid design allows for versatility in operation, making it suitable for a range of flight profiles. As a ramjet, it does not rely on a compressor before combustion. Instead, it uses the forward motion of the aircraft to compress incoming air, which is highly efficient at high speeds. Its ability to switch between turbojet and ramjet modes is crucial for its first aircraft quarter horse, which can take off from a standard runway and then accelerate to high Mach speeds, enabling it to operate efficiently in various flight regimes. Space Engine Systems is a Canadian company involved in the development and testing of advanced propulsion technologies, specifically ramjet engines, with a focus on multi-fuel capabilities, including hydrogen. This versatility is a significant asset, allowing adaptability in different aerospace applications and mission profiles. During the testing, SCES has observed the formation of supersonic diamonds. Supersonic diamond patterns can appear when shock waves interact with the engine's exhaust flow, indicating the rapid acceleration of the ramjet-powered vehicle. The SR-71 Blackbird is one of the most iconic and legendary aircraft in aviation history. It is a high-speed high-altitude reconnaissance aircraft developed and operated by the United States Air Force until its retirement in 1998. The aircraft was famous for its incredible speed as it could reach sustained speeds of Mach 3.2 or approximately 2,200 miles per hour. At its top speed, it could cover the length of a football field in less than a second. It featured a unique design with a slender fuselage and forward-swept wings which reduced its radar cross-section. Its speed and altitude capabilities allowed it to evade potential threats and fly faster than enemy missiles or interceptors could catch it. On the 22nd of December, 1964, the first flight of the SR-71 Blackbird was at the United States Air Force's Plant 42 in Palmdale, California. Such a flight was crewed by Lockheed test pilot Bob Gilland, who served as the pilot and USAF major. During the first flight, the SR-71 achieved a top speed of Mach 1.5, which was relatively modest compared to its eventual capabilities. The aircraft's initial flights focused on subsonic and transonic flight regimes before gradually pushing into supersonic and hypersonic speeds. In addition to the United States, Great Britain and France have had their equal share of putting time, money, and effort into making supersonic commercial flight possible. In fact, these countries together built the first supersonic passenger-carrying commercial airplane, a technological masterpiece known as Concorde, which made its first flight on the 2nd of March, 1969. The Concorde could attain a maximum cruising speed of 2,179 km/h or Mach 2.04, ultimately reducing the flight time between London and New York to almost 3 hours after its revelation as the world's first scheduled supersonic aircraft. Concorde was flown to several destinations worldwide. However, its noise and operating expense limited its service. In 2003, the financial losses led both British Airways and Air France to cease Concorde operations all over the world. However, there was a blessing in disguise. This development proved that European governments and manufacturers could cooperate in complex ventures and ensured that Europe would remain at the technical forefront of aerospace development. The future of supersonic flight took a big hit with the retirement of the Concorde. However, its heir, the Boom XB-1, held the reins and revived its legacy. Boom XB-1 or Baby Boom is a 1/3 scale trijet supersonic demonstrator designed by Boom Technology as part of the development of the Boom Overture supersonic transport airliner. In 2022, the XB-1 conducted a low-speed taxi test to officially inaugurate its flight testing phase. This was followed by medium-speed and high-speed taxi tests, during which the XB-1 accelerated to a speed of 140 knots, which is almost the same as its takeoff speed. The XB-1 features 3 General Electric J85 engines which deliver a combined thrust of 12,300 pounds and allow the aircraft to maintain a speed of Mach 2.2 with over 1,200 miles of range. On the 22nd of March, 2024, Boom XB-1 safely and successfully executed its first flight at the Mojave Air and Spaceport in Mojave, California. In addition, AT-38 aircraft took off to chase and monitor the XB-1 in the air. Boom is expected to roll out its first Overture aircraft in 2026 and introduce it to service by 2029. For its production, the company built a special Overture superreactor which is expected to be at least 40% more energy efficient than similar manufacturing facilities. With the building now complete, Boom is focusing on starting production. To expedite the process, the company is procuring and installing tooling in the superreactor, beginning with an advanced test cell unit, which will be used to develop manufacturing processes, optimize the flow of the assembly line, and prepare staff for Overture production. The development phase of an aircraft is challenging, and it sometimes leads to serious problems in its design and overall system. To avoid this, the engineers built what's known as an Iron Bird to test and verify critical aircraft systems. It is a ground-based test rig used for prototyping and integrating aircraft systems during the development of new aircraft designs. Different aircraft systems are installed into the Iron Bird so their functions can be tested both individually and collectively with other systems. The boom has planned to develop an Overture Iron Bird, a full-scale model that will be used to test and integrate Overture's flight systems, software, and hardware components that will actually move. Overture's Iron Bird would be located at Boom's new 70000 QT facility called the Iron Bird. This facility features Systems Integration Labs (SIL), which include the Iron Bird test model and fully functional flight deck simulators. As the X-59 Quest nears its historic first flight, it represents more than just another experimental aircraft. It symbolizes a turning point in aviation history. With decades of supersonic innovation behind us, from the SR-71 Blackbird to Concorde and now Boom's XB-1, NASA's Quest mission brings us one step closer to making quiet overland supersonic travel a reality. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.